I'm Parveen Yaqub. I'm Deputy Vice-Chancellor at the University, and I'm absolutely delighted to welcome you here today for the Children's Spring Lecture, which is about wind of change, curbing cow burps to fight climate change. So today's speaker is Chris Reynolds. He's a Professor of Animal and Dairy Science, and he's also Director of the Centre for Dairy Research on the university's farm. There's probably nothing about cows that Chris doesn't know. But he's going to share some really important insight about their burping behaviour. And apparently we're going to find out whether the university's cow herd can burp the National Anthem, why cows burp and why that's bad for the environment, and whether we can do anything about it. Now, I would suggest that if you're going to make any sound effects, you wait for a cue from Chris, but there will be a chance to ask questions at the end. So if you've got any questions about anything to do with cows, save them up for the end. I think he is happy to answer questions during the lecture as well, but if you have any questions, there should be some time at the end. And then finally today, we are filming today's lecture. There's a camera at the back, but it's not going to film anybody in the audience, and it's not going to film the questions session, so you don't need to worry about that. So without further ado, let's give a very warm welcome to Chris Reynolds.
Thank you, Parveen. Thank you very much, Parveen, and thank you all for coming this afternoon. I was honored to be asked to give this presentation today, and I'm very pleased that so many of you wanted to come and hear about burping cows. So I've been talking long enough for you to know that I'm not from around here. I'm originally from Nashville, Tennessee. So if you can't understand the way I talk, then please don't hesitate to put your hands up and ask me a question or ask me to clarify if you don't understand me. I will say that coming from Tennessee, from Nashville, Tennessee, which is the home of country music, my claim to fame is I once met the king on a lift. And I'm not talking about Charles III, I'm talking about Elvis, the king of rock and roll. So you probably don't know who Elvis is, but your parents do. So I just thought I'd throw that out. And I really did meet him on a lift in a Sheraton hotel when I was a kid. So I came over from America 30 years ago to work here at the University of Reading, and everybody asked me, why in the world would you leave the United States and move to England, of all places? And I'd say, well, because the University of Reading is so famous, it's such a great place to work. But the real reason was I married an English woman, and it was a lot easier to move me to England than to move her horse to America. And we still have a horse, and I actually have some feed from the horse that when I fed the horse this morning, I picked up some hay to show you as part of my lecture. So the horse still rules the roost in our house. So what am I going to talk to you about today? Well, I'm going to tell you a little bit about our university farm and our dairy research facilities at the university. I think I learned to milk a cow when I was about 5 years old. My uncle taught me how to milk a cow. And I've loved cows ever since. I've been working with them my whole life, and I just think they're amazing. So I'm going to tell you a little bit about why I think cows are so amazing, about how they can convert grass into milk. I'm going to tell you a little bit about why their digestive tract, why that process of eating grass results in burps. And they do a lot of burping. They do a little bit of flatulence, farting, but they do a lot of burping, okay, eructation. So I'll talk about that, why that happens, and why we need to worry about it, and that's about climate change and methane, and then how we study it at Reading, and I'm going to tell you about some of the research that we've been doing to try to reduce the amount of methane that cows burp, okay? So that's what I'm going to be doing today, and I hope you enjoy it and you get something out of it. So we do a lot of dairy research at the Center for Dairy Research, but here at Reading, we do a lot of other research related to agriculture and food. We're internationally known for our research in agriculture and food, okay? So our Center for Dairy Research is at Hall Farm, which is south of the M4, but we also do a lot of other types of research on other types of animals, and we also do crops and soils research related to agriculture, and some of that is done at Sonning Farm, which is up northeast of Reading on the River Thames, okay? But our Center for Dairy Research is here south of the M4. And there we're currently milking about 540 cows. We currently sell about 6 million liters of milk every year. And we sell that milk to Arla, who then sell it to Sainsbury's. And so if you've bought a jug of Sainsbury's milk, then you've probably had some milk that came from one of our cows, okay? We milk the cows on a rotary parlor or a carousel. It's kind of like a roundabout that the cows go onto. And we milk them on that type of parlor, because it's very efficient. We can milk the cows very quickly, and that gives the cows more time. They don't have to wait to be milked. They can spend more time eating and laying around and resting, okay? So our cows produce a little under 11,000 liters of milk every year. That's milk sold every year. And so as I was showing in that picture I just shown, that's about almost 30 of these every day that one of our cows produces across a year, annually, on average. So 30 of those a day, that's the amount of milk that our cows are currently producing. Okay. So what do we feed our cows? What do they eat? So cows eat grass. Okay, they eat forages, or what we call fodder. And for this fodder, this forage, is high in fiber. It contains cellulose. Okay, and they graze it. They go out and walk around and graze it. They pick it up with their mouth and their tongue and their teeth, and they break it off and they eat it and swallow it. But sometimes it's very dry here at Reading, and so we can't rely on the grass to grow to feed them. So we have to harvest the grass and conserve it. Okay, and so that means we have grass that we can feed them in the wintertime, or we can have grass to feed them when the pastures are too dry and they're not growing. Okay, so we take grass, like this fresh grass I picked I cut in our horse's paddock this morning, and we put it into a clamp, which is a big container, and we pack it down to get all the air out of it, and we seal it, and then it ferments. So microorganisms break down some of the sugars in this fresh grass, and they produce acids. And when they produce acids, it pickles the grass. It literally pickles it. And I don't know if any of you smelled any of these silage samples that were outside, and whether you thought it smelled like pickles or not, but the acids that are produced are things like acetate, which is in vinegar, and propionate, and butyrate. And butyrate in particular has a specific smell. So if you touch this, there was a sign saying don't touch it, but if you touched it, your hand probably smells like silage now. It'll wash off, and I'm kind of used to it. I like it. It smells all right. And the cows love it. They absolutely love it. But it's a really good feed for cows. So it's been preserved by fermenting it anaerobically without oxygen. Okay? And we're going to come back to that concept of fermentation and microbial fermentation producing acids as another part of the lecture. Okay? So that's grass silage, and we also had some maize silage. We grow maize, forage maize, and we chop it and ensile it the same way. And the other way we can conserve grass, or after it's harvested, is just to dry it out. And that's what hay is. It's just this fresh grass that's been dried out. Okay? And when it's dry, it keeps, so it doesn't spoil. And so we can keep it for years once it's been dried, and then we can feed it to our cows. And we feed some hay and some straw from wheat crops and things like that. And those are forages or fodder, and that's what cows eat, and that's what they rely on. So this grass here. Oh, and by the way, I should have said, here's some pictures of us harvesting grass to make grass silage at our sonning farm along the River Thames. And notice the red kites. We were taking these pictures with a drone, and the red kites came out to watch our grass harvest. So I think that's a pretty cool picture. So anyway, cows eat grass. Can we eat grass? No, absolutely. Well, we can. We can. Sometimes I suck on it. It's got some sugars in it. You know, you can put stem of grass in your mouth, and when you come from the country like I do, you know, you can suck on a piece of grass. But we can't live on grass, can we? And why is that? Why can't we eat grass? We don't have the same organs as cows in our digestive tract. You're absolutely right, okay? We don't have a digestive system that's designed to eat grass, but cows do, okay? And so because of that, cows, like these are beef cows from our dairy herd down at CEDAR, and they're grazing some wildflower meadows down at Langley Mead Nature Preserve, which we manage down the River Loddon. So they're able to eat grass, which we can't eat, and they can turn it into things like milk, and if we want to, meat that we can eat, okay? And we can grow that grass on land that's not suitable for growing human foods. So it's a really good way of producing food from grass. So how is it that cows are able to digest grass? You said they have the organs that let them do it. And the really important organ is their rumen, okay? So cows are ruminants, right? And not just cows are ruminants, but sheep and goats and deer and other wild animals like antelope, they're all ruminants, okay? And ruminants are very special. They have two sort of characteristics. We all know cows have 4 stomachs, right? Right? Okay? They have to eat a lot to fill up all 4 stomachs, yeah? So ruminants have 4 stomachs, okay? And let me just tell you a little bit about those 4 stomachs. There's a picture of them up here, and this model that I brought in has those 4 stomachs as well, okay? So one of the stomachs, the last one, is called the abomasum. And that's what we call the gastric stomach. And that's the stomach that works pretty much like your stomach does. It secretes all the enzymes, the same enzymes and things like that. They also have an omasum. And believe it or not, we've been studying cows for hundreds of years, and scientists still don't know exactly why a cow has an omasum. But one of the things that the omasum does is it absorbs lots of water, and it absorbs some minerals, and some of the acids from fermentation, and we'll come back to fermentation in the rumen. And that's the omasum there, okay? And the food flows out of the rumen through the omasum and into the abomasum. But the main part of the cow's stomach is the reticulum and the rumen. So there's the reticulum and there's the rumen. And the reticulum is like a pump. It squeezes and it pumps digesta through all the contents in the rumen and helps to mix it. And the rest of the rumen is divided up into compartments, and it's a huge fermentation vat. So there's lots of fermentation that goes on in there by microorganisms. And it's the microorganisms, like bacteria, that break down the cellulose and the fiber in the cow's diet and enable the cow to digest it. So it's microbial fermentation in the rumen that's really important. So cows have 4 stomachs. They have a rumen where there's lots of fermentation that goes on. But the other thing about cows that makes them a ruminant is they ruminate, okay? And the word ruminate comes from ruminare, which means to chew over. And sometimes I've heard it called to think over, so to think about things. And if you ever, I'll show you a video of a cow ruminating in a minute. But when cows are ruminating and chewing their cud, it's like they go into a trance and they just chew. And it's like they're thinking, and they're thinking things over, okay? And so what they do is they chew their cud. So they eat lots of food, okay? And then they go lay down and they kind of throw it back up. They regurgitate it and re-chew it, okay? And so they're cud chewers. And so that fiber in that grass that we can't digest, they can digest it because microbial activity or fermentation breaks down the cellulose in the reticulorumen. And it's constantly being mixed, okay? It's like a big fermentation vat. And the reticulum is pumping the liquid through the digestive particles and mixing the bacteria with it and the microorganisms. And these strong muscular contractions are constantly mixing it, okay? So what I was always taught was that when wild ruminants are out grazing and they go out to graze grass, they're out in the open and they worry about wolves and lions and maybe tigers eating them, predators. So they go out and they eat as much as they can, as quickly as they can, and they fill up their rumen, and then they go hide somewhere and lay down, and they regurgitate their cud and chew it. So they don't chew it very, your mother always tells you, or your father when you're eating, be sure to chew your food before you swallow it. Make sure you chew it. I don't know, I was told 20 times before I swallow it, because you don't want to swallow it without chewing it enough. Well, cows go out and they don't chew it enough because they're worried about being a wolf coming along and maybe killing them. So they eat really quickly, and then they fill up their rumen, and then they go hide somewhere. Well, not our cows, but a wild cow would do that. And then they'll chew their cud. And if our cows on the farm are being fed the right kind of diet, they will eat about 8 hours every day, and then they will chew their cud for 8 hours a day. So they spend 16 hours a day just chewing, eating, and then chewing their cud. So they spend a lot of time chewing. And that's how they break down the grass, which is hard to digest. It's really hard to digest. So here's a picture I took of some cows chewing their cud. And if I'm going onto a farm to evaluate a farm's diet, I'll want to know how many cows are chewing their cud, and when they regurgitate a bolus of digesta, how many times they chew it. Okay? Because it tells me a lot about whether that diet is adequate and has enough effective fiber in it or not. So you can see those cows. Now those cows aren't sort of thinking there because they're watching me because I was videoing. And here's another cow. I'm going to show you this picture. And watch what happens at the very beginning. The cow sort of inhales, and then there's pressure on her stomach, and she regurgitates this bolus of cud, and then she'll chew it. Okay? Did you see her? She went, and it regurgitated, and she chews her cud. So if I'm evaluating that cow's diet, I want to know how many times she's chewing their cud when she regurgitates that bolus. And so cows are really, really good. Well, they spend a lot of time. They're good at chewing. They're very good at chewing. So rumination. Cows are ruminants. Rumination is the regurgitation and chewing of a digestive bolus or a cud. Cows chew their cud. And it breaks down the particles of the feed. And it gives those particles more surface area. It makes them smaller so the microbes that are going to digest those particles have more surface to attach to it. Okay? So that's how it works. It exposes it to to microbial attachment. And again, I said they're going to ruminate up to 8 hours a day. They chew about 42,000 chews every day. It's like they're on chewing gum just constantly, just chew, 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 chew. The really important thing about the chewing as well is that while they're chewing, they're producing saliva. And cows produce lots of slobber, a lot of slobber, okay? 200 liters a day, okay? And that saliva is really important because it contains buffers. It contains sodium bicarbonate. Have you heard about soda, sodium bicarbonate, baking soda? Your mother and father probably got it in the kitchen. You cook with it. It's baking soda. And what it does is it buffers acids. It acts as a buffer and neutralizes the acids that are being produced in the rumen, those volatile fatty acids. Okay? So that's really important for the cow so that she doesn't get an upset stomach from all that fermentation. So that chewing produces saliva, lots and lots of saliva. And it helps keep her stomach healthy. Okay? If you've got an ulcer or sort of an upset stomach, you might take some sodium bicarbonate to try to make your stomach feel better. Well, cows get that by chewing and producing all that saliva. The other thing about the cows that's really amazing is how many microorganisms they have in their stomach. Now, I told you they have microorganisms in their stomach. Every cow has about a quadrillion microorganisms in her stomach. That's 1,000 trillion bugs, microorganisms, okay? So a lot of them are bacteria, these little guys, and a lot of them are protozoa, and there's some fungi as well. And they're the workhorses. They're the ones that, it's not the cow that's digesting that fiber, it's the microorganisms in her stomach that break it down. And so I've got a little video here of some rumen fluid and they move around and they go find fiber particles Okay, 1,000 trillion of these in every cow's stomach. And that's not including all the ones that are in her large intestine and her small intestine. Okay, so, and they're the workhorses. And they attach themselves to those fiber particles, and they digest it in the cow. Okay, so it's a process of fermentation. And you've studied about fermentation in school probably, right? You know a little bit about fermentation. So we can use fermentation if we're going to make wine or beer. We have yeast ferment sugars and they produce ethanol. Or we can have lactic acid producing microorganisms to help make cheese. We can use yeast that break down sugars in starch, and then they produce carbon dioxide to make our bread rise. And in our large intestines, we have microbial fermentation as well. And that produces gas, and that causes us to have flatulence, farts, right? Okay? And that might be gases like hydrogen, or it might be methane. Okay? If we have a certain type of microorganisms in our digestive tract called an archaea produce methane. And of all of you out there right now, probably a third of you produce methane when you fart, and about 2/3 of you don't. And basically, if your mother produces methane, you probably do, because you got your microorganisms in your digestive tract mostly from your mother. Okay? So that's kind of how that works. So fermentation produces a lot of gas. So cows have got a quadrillion microorganisms in their stomachs breaking things down. They're producing a lot of gas. So cows have to burp. They have to burp a lot of gas. So the breaking down that fermentation, the grass and the other forages in their stomach produces a lot of gas. It produces CO2, but it also produces methane. And for the cow, most of that methane's being produced in her rumen. She produces a little bit in the back end in her large intestine. But everybody asks me about farting cows. I've been talking about farting cows for 30 years. I've been interviewed about literally more than 30 years now. Everybody wants to talk about farting cows because it's kind of funny, isn't it? You know, farting. Yeah, and you can say it on the news. You can talk about. It's fun for me to say farting cows. It's fun right now, but it's also serious because it's about methane, and we're going to talk about why methane is important in just a minute. Okay. So cows produce about 600 liters. Our cows at CEDAR, it depends on how much they eat, but they produce about 600 liters of methane. And if we look at a balloon, it'd be a balloon about 1 meter across. So it's probably about 25 or 30 of those balloons of methane that our cows produce every day. And that's a lot of methane, okay? It's a lot of methane. So it's mostly eructation or burps, not farts, okay? So how many of you ever been on a farm with cows? All right, how many of you heard the cows burping? Has anybody ever heard a cow burp? If you were a wild cow back before they were domesticated, and you were hiding from wolves and you'd gone off to chew your cud, and you didn't want the wolves to know where you were, what would you do if all your herd mates were lying around burping really loudly? The wolves would know exactly where you were. So it's kind of like when you're at the dinner table with your grandparents, you know, and you suddenly feel like you need to burp, but you know you're not supposed to burp out loud, so you burp with your mouth closed. And that's what cows do. They burp with their mouths closed, and they actually close the nares in their sinuses so that the gas doesn't come out. And then they inhale the burp into the lungs, and then they exhale it. So it's really, really quiet. And you hardly ever, unless a cow's just by accident got her mouth open when she burps, you hardly ever hear a cow burp. So they don't burp out loud. Why are we worried about cow burps? How many of you heard about global warming? Yeah, methane, very good. Methane is a greenhouse gas, okay? And it's estimated that about 1/3 of human-caused methane emissions come from livestock. And most of that's from our ruminants. That's cattle and sheep, a little bit of goats. But it's mostly cattle and sheep. So our country has made a pledge to reduce methane emission by 30%. So reducing methane emission from cattle is really important in terms of reducing climate change. Okay? So that's why we've been doing work at the University of Reading on how can we feed cows in ways to reduce the amount of methane that they produce. So hopefully I've explained where methane comes from and why cows produce it, and why it's important that they burp. But I want to talk to you a little bit about some of the research we do. And we've been doing this research for over 20 years, and it's really now coming to fruition. Products are coming onto the market that we can feed the cows to help them reduce their methane emission. So again, I've been talking about this for so long, and there's been so many stories about farting cows and feeding cows beans to make them fart, or whether we should or not. So there's been a lot of work in this area. And some of this work that we've done at the University of Reading has been in the BBC website. Okay. So how do we measure how much methane a cow burps? Right? One of the ways we do it is we have something called a respiration chamber. So we can put cows in these respiration chambers and close the chamber up, and then we measure everything that goes into and out of the chamber. The cows do okay. We always make sure there's windows so they can see other cows and they don't go in there, they're not on their own, okay? And the other thing we do is we've got these really nice water beds for them to lay on when they go in. They absolutely love the water beds. Sometimes we have to drag them out because they don't want to leave because they like the water bed so much. But they do. And so we measure all the air that flows through the chamber, and then we measure the change in the concentration of gases like CO2 and methane as it comes through the chamber. And that's how we really precisely measure methane emission from cows. So when we do research with animals, we have to follow the 3 R's: reduce, replace, and refine, to try to minimize the amount of research that we actually do with cows. So one of the things we do is before we test a product actually with a cow, is we'll test it in the lab using an in vitro system. So we've got 2 different types. One is a batch culture system, or a continuous culture system, where we use rumen fluid and feed, and then we change what we feed these fermenters with to see if it will reduce the amount of methane that's produced. So we test a lot of these products in the lab, in vitro it's called, in the test tube, before we test it in the cow. We have another system, which is a portable system. It's a really neat little system. It's a portable head chamber, and the cow can voluntarily put her head in. And when she does, she's got an electronic identification tag in her ear. The machine knows which cow it is, and if she's allowed to, because she can't spend all day in there, we won't let her. If we let the cows, they would eat all day in this machine. We only let them go back every 5 hours. And it's hooked to the internet with a SIM card, like your mobile phone, and we can watch. It's got a video camera, and I can sit in my office here on the campus, and I can watch cows going up to this down on the farm. And while they've got their head stuck in, it measures how much methane they produce while they're eating. So we use that a lot because it's not like putting a cow into a chamber. We leave it out and the cows are out grazing or whatever, and we can measure how much methane they produce. So we've done a lot of work with this system over the years to measure methane emission. And it's important because methane's a very powerful greenhouse gas. It's got a short half-life, which means it doesn't stay in the atmosphere as long as carbon dioxide or nitrous oxide or other greenhouse gases. And if we can reduce the amount of methane, we'll have a very quick effect on global warming because methane disappears so quickly. So it's why there's such a big push to reduce how much methane is being produced. And in our studies at Reading, if we look at how much methane cows produce, if we compare how much they eat with how much methane they emit, in this case it's methane energy, basically how much methane a cow produces is partly determined by how much she eats, because that determines how much material goes into her rumen to be fermented. Okay? But, thank you. We need that so people can hear me. It's because I'm waving my arms. I told you, I'm from Tennessee. When I'm talking, I wave my arms. Okay? But if you notice, for a given level of feed that a cow eats, this is feed dry matter intake. So cows can eat up to like 30 kilograms of feed dry matter a day. The amount of methane that's produced varies, okay? And so we've been studying why it varies. Some of it's genetics of the cow, okay? It could be something we could select cows that have lower methane emission. I'll come back to that. But a lot of it's the type of diet that they're fed. And so what we're trying to do is push this line down, okay? Can we formulate a diet, put together a diet in a way that the cow produces less methane, or can we add things to the diet so that the cow produces less methane? And we have tested loads of things. We've tested all kinds of things that have been shown in vitro to reduce methane emission. One of them that's in the news a lot is garlic oil. So garlic, when it grows, it produces compounds in oil that are antimicrobial. So they protect it. If it gets injured when it's growing in the soil, it protects it from microbial invasion. The compounds called allicin. Okay? So we fed garlic oil to cows, lots of it, because it works really well in vitro in a lab. But what we find is that sometimes things that work in vitro don't work as when we put them into a real cow where the rumen's mixing and there's a lot of rate of passage of digesta through the rumen. Sometimes they don't work. It did produce some milk that tasted just like garlic. It was disgusting, absolutely disgusting. So if you wanted some natural garlic flavored butter, that would be the way to do it, but it didn't do anything to methane. And we've had failures before, okay? We've worked with commercial companies like DSM, and DSM are now building a plant in Scotland to produce a compound that they've invented that works very effectively at reducing methane. It's being trialed currently in places like Denmark and Belgium, and when it's fed to cows, it reduces their methane by about 30%. Okay? And we were the first research organization to feed that product to a lactating dairy cow here at Reading. Okay? And it's something that will work and is going to work, and it's already being fed in other countries, as I've said. We've done a lot of work on feeding seaweed. Believe it or not, seaweed. Everybody talks about seaweed. Everybody's interested in seaweed as something that we can feed to cows to reduce methane emission. And we've done a lot of work in this area. It works really, again, a lot of seaweed works very effectively in the lab, in vitro, but we found it doesn't always work in cows. The other thing is seaweed is really high in iodine. And there's legal limits to how much iodine we can add to a cow's diet because too much iodine in milk can be bad for children's health. So we can only feed so much iodine. So it means we can only feed a little bit of the seaweeds that are most effective at reducing methane. Okay? And finally, you've been given some sunflower seeds. The other thing that works really well about reducing methane from cows is feeding fats and oils. We can only feed a little bit because they kind of muck up the fermentation in the rumen. But sunflower hearts and sunflowers are really good feed for cows, as are rape seeds. We've done a lot of work on feeding rape seeds. We grow a lot of rape in this country. If we leave the fat in it, rather than extracting the oil to use in salad oil or something like that, and feed it to the cows, it's a really good way to reduce methane emission. And the cows will actually produce more milk, so the farmers like it, because their cows produce more milk and they produce less methane. So there's some data. I wanted to put some actual data from one of our trials into the talk, okay? So this is data from some cattle that were fed different feed supplements. And this is how much methane they produced in grams per kilogram of dry matter intake. So remember we were looking at, we want to reduce the amount of methane per unit of feed they eat. So they were fed a control diet, or they were fed a diet lintek, which is extruded linseed. It's linseed seeds that have been heat treated and it's still got its oil in it. We fed Asparagopsis taxiformis, which is a type of seaweed that has a compound called bromoform in it that's really effective at reducing methane. But it's really high in iodine, so we could only feed a little bit. And then we fed nitrate, which is a nitrogen compound that sucks up hydrogen in the rumen. And methane comes from hydrogen reducing CO2 in the rumen, so that's another way of reducing methane. And what we found is the supplemental fat, the linseed, and the nitrate both reduce methane. The seaweed worked a little bit, but it wasn't significant, we call it. And that's because it was so high in iodine we couldn't feed enough. But that's just an example. And linseed is something that farmers are feeding now and will reduce methane. And nitrate, there's a product that a company called Cargill has that's being sold to feed to cows to reduce methane. And in Australia, they have a program where farmers can feed their beef cattle nitrate as part of a carbon trading scheme. So they reduce the amount of, and it's known to reduce the amount of methane they produce. And finally, I wanted to mention herbalaise. Do any of your parents listen to the Archers on the radio? Nobody listens to the Archers. I've got one. You know about herbalaise then. Everybody has herbalaise on the organic farms in the Archers. Okay, herbalaise are very popular right now because they're really good for the soil. We talk a lot about regenerative agriculture right now here in the UK. And herbalaise they're pastures that have a lot of different species in them, not just grasses, but legumes that capture nitrogen and herbs like plantain and chicory. And they're really good at improving the soil and helping to capture carbon in the soil when they're growing. But we've shown that they also reduce methane when cows consume forages that are based on herbalaise, then their methane emission is reduced. And it's because of some bioactive compounds in some of the herbs that are in those herbalaise. Okay, so I'm disappointed none of you but one listened to the Archers. That's very disappointing. Anyway, but you would know about that. So finally, a couple of other things that people are investigating. I'm about to finish. One is people ask me all the time, well, if cows are producing so much methane, why don't we just put them indoors and capture the methane and use it for fuel, right? And it sounds kind of far-fetched, but there's actually a lot of research going on about doing just that. There's a big project at one of the agri-tech centers here in the UK that's looking at methodology, because we often have to put cows inside, especially in the wintertime. And so they're looking at ways of capturing the methane coming from the cows inside. And there's another company called ZELP. ZELP stands for the Zero Emissions Livestock Project. And we've been working with ZELP because they like using our chambers, and they're developing technology to try to capture the methane that a cow produces, to measure it first of all, but also to capture it and oxidize it, to break it down back into CO2, so it doesn't harm the environment and contribute to global warming. Again, very far-fetched, but it's really, they've got loads of funding from King Charles III. Sorry, I said he was Prince Charles when he gave him the money. But they're very innovative, okay? And the technology is really incredible. And it's a really neat way of monitoring how much methane a cow produces, if nothing else. But notice the capturing device is over the nose, it's not over the mouth. Remember, cows don't belch or burp through their mouth. They burp through their nose. It comes out their nose. And that's what this technology is about. Another thing that we do, and farmers do all the time, is they just try to do a better job of managing their cows, to make sure their cows don't get ill, to make sure that their cows are fed as best they can, and that way we get more milk with fewer cows. And so that's another thing the industry is doing, is just to try to improve our management of cows. And the other thing we can do and we're doing it already, is to use genetics, okay? And we can use DNA markers. We actually have DNA markers that can tell us how much methane a cow will produce compared to other cows. So when a calf is born, we can take a blood sample, analyze it for its DNA, look for, we call them SNPs, and predict how much methane or how efficient that cow is going to be. And so we already have breeding indexes where farmers can say, okay, I've got a cow here that produces less methane. I'm going to keep her daughters in my herd, and I'm not going to keep daughters of cows that produce more methane. And so that's genetic selection. We're selecting cows that have that produce less methane and are more feed efficient. So they produce more milk for the amount of feed. And the UK is the first country in the world to have an environmental selection index for its dairy herd. So dairy farmers in the UK are able to pick cows that they want to keep in their herd that are more environmental, have less impact on the environment. Okay. So, cows burp. I haven't actually burped, have I? I could try to burp, but it probably, I'd have to drink a Coke or something like that. Cows burp a lot of methane, and it comes from fermentation of feed by that those quadrillion microorganisms in their stomach. We've done a load of research, and there's research being done all over the world about how to manage cows to produce less methane. We can change what we feed them. We can give them more digestible grass. That helps. We can give them herbal lays, or we can add supplements to their diet like fats and oils or nitrates or some of these commercial enzyme inhibitors. And there's actually research going on capturing methane. Really important thing that farmers do already, and we're working so that they can do it better, is to manage their cows so they have better health and through management. And that really helps reduce methane emissions as well. And genetics is going to be really important going forward. Very, very, very important. So, could one of our cows burp the national anthem or not? What do you think? Yes? If they did, would you hear it? No. Absolutely right. So even if I could train one of our cows to burp the national anthem, it'd be quiet. It'd be so silent you wouldn't hear it. Yes? And if they did, yeah, they might actually burp a little bit more if they were trying to burp the national anthem. So finally, thank you very much for listening. I hope you've got something out of it. And I found these two cows at a farm locally, a cow that had a heart on her head and a cow that had a question mark. And I would love to take any of your questions.